Howdy, AP PreCal. It is Ms. Kosh. We are continuing the way I want to teach trig equations and inequalities. This is section 310 for AP PreCal. I have done 2 examples. This was kind of what we worked through, so go find that video. And also, I'm working off the assumption that you know what my kids know, which is they're really good at the unit circle, or they should be. Most of them are, and they know how to graph the trig functions, and they're learning inverse trig and that kind of stuff. And so we're going from there. So I have 2 more examples that I want to work with you. We'll see if it's 1 video or 2. All right, let's jump in. Let's do this. So on this one, they give us 2 functions, f and g, and they say solve it on that interval. So, okay, sine of x equals 0. When does sine of x, this is straightforward, unit circle. Sine is the y value, it equals 0. So on that interval, it's going to equal 0 at 0, and at pi, and at 2 pi. Okay, so if we said find all, which we didn't, it would be pi k. This would be all. Assuming, of course, that k is an element of the integers. That was not the question they asked, but there you go. Okay, so then the next one says solve the equation on the interval, solve the equation g. Okie dokie. So subtract 1, divide by 2, cosine of x is equal to negative 1/2. I think I keep using negative 1/2 in all these problems, but that's great. On my unit circle, when is cosine negative 1/2? Here and here. So x would equal, on that interval, it's going to be 2 pi over 3, and then it's going to be 4 pi over 3. Okay, so then it says find the set of values. Well, before we do that, we're going to do the inequalities, but before we do that, it might be helpful to create a sign diagram and or sketch it. Okay, so let's do, actually, I'm going to make this green. I'm going to make style green. There it goes. I'm going to do F in blue and G in green, and we'll just kind of stick with that. Okay, so then it tells us to graph F, which is just sine of x, okay, on the interval negative pi. So it's this. We go up as high as 1. We go down to 0. If you can't go as fast as me right now, then you need to do some more practice, because we've already quizzed in my class on graphing trig functions. Notice I'm trying to get the concavity right. There we go. So there's my sine curve, and let's do the 2 cosine of x plus 1. It's got an amplitude of 2, but it's been shifted up 1. So cosine starts at the very top. So we're going to be at 3. Then we go to 1, and then we go all the way down, but it's now negative 1. Hopefully I'm getting all these little values correct. Let's back up to, where is this going to be? At the midline, and this is going to be here. Okay, so we're concave up, concave down, concave up, concave down, concave up, and there we go. Okay, so there are my graphs. And we know, okay, we know that this graph right here, this would be 2 pi over 3. And this right here would be 4 pi over 3. Because we solved that equation just a minute ago. Okay, so now looking at this, let's see the sign diagrams. There we go. We'll do the sign diagram for F. Here's F sign diagram. So I have 0, I have pi, I have 2 pi. And actually, maybe I should make everything dotted. Dotted, because those are zeros. Okay, and then what would happen, so we'll sign between 0 and pi is positive, and between negative pi, I lied, between pi and 2 pi it's negative. That's what I wanted to say. We know that from the graph. We're just really good at graphing sign, and it just kind of seems obvious. We could plug in pi over 2 and see. Okay, so my G, I'm looking at, what did I find? I have 0 and 2 pi again, but those are not zeros, so I'm not going to make them dotted. But I had a 0 at, what was it, 2 pi over 3, and I had a 0 at 4 pi over 3. Okay, so between 2 pi over 3 and 4 pi over 3 is pi, and so we can say g of pi would be equal to 2 cosine pi plus 1. Cosine of pi is negative 1 times 2 is negative 2 plus 1, so that equals negative 1. So this is going to be negative. And so it's positive, negative, positive. Okay, so let's answer these questions. Where is f of x less than 0? f of x is less than 0. It can't equal 0, so it's going to be soft brackets on pi to 2 pi. Where is g of x greater than 0? Well, looking back at this, 0 to 2 pi over 3, and then 4 pi over 3 to 2 pi. But we can't include this. Oh, I was going to use green. 0 to 2 pi over 3, pick it up again, and go from 4 pi over 3 to 2 pi. Super. Okay, and now they want to know where do both things happen. So where is f of x less than 0? So looking at the graph, I need to, that narrows my world down to where is it less than 0 from here to here. And so inside that world, where is g of x greater than 0? So where is g of x greater than 0? Well, from 4 pi over 3 is where it then becomes, so 4 pi over 3 to 2 pi. Okay, yeah, because we needed both of these things. You can kind of look at the two sign diagrams together, kind of put them. We wanted to, it was going to be true, and when that one was negative, and it was going to be true. I don't know why I wrote an F. I meant to write T for true. True here and true here. So one was true when it was negative, the other one was true when it was positive, and we had to go with the smaller group. Okay, this next one is fun. Okay, you ready for this? So yeah, here we go. Let me start by graphing. Okay, so we have an amplitude now of 8 and we're a shift up of 7. I think each little line is 1-ish. So here's 1 and then 7, not 1. We're graphing, that's the midline at 7. And then we're going up an amplitude of 8. So 7 plus 8 is 15. And then we get back here. And then 7 minus 8 is -1. Oh, I don't know why I deleted that. And then here, and then we come back up to 15, and we go back to our midline. And then from here, we come down to -1. And so it's graphing, what is that, like a period and a half? Or no, I guess it's 2 periods. It just starts weird. Yeah, because there's 1 period. Here comes the second one. Okay. Okay, so here's our graph. And now they're saying live on, we're going to ask us about values between 0 and 2 pi. So we can see here is 0, here is 2 pi. Nope, is that 2 pi? I lied to you. Here is 2 pi. So you can see that there's two values here where they intersect. So there's two solutions, and now let's go see what happens. So when I come over here and set this, 8 sine of x plus 7 equal to 0, I get sine of x is equal to -7/8. Okay, well, so that is not unit circle friendly, but now we have started learning how to use the inverse sign. So when we do, we will say x is equal to inverse sign or arc sign, you could write either one, sine to the -1 of -7/8. But there's a problem. They told us to live between 0 and 2 pi. And this answer, this is saying we have, that looks funny, but okay. We're at -7/8, and the inverse sign gives me this angle right here that is negative. And so what I want is, I want the answers between, and actually, we're going to have two places where we intersect the circle. But we're going to talk about the second one as we keep going. So this first one, though, what I found actually got there in the negative way. So I just found some negative value. I don't know what it is, and well, maybe it would be helpful to figure out what it is. Let's see. Do I have Desmos open? I do. Okay. Oh, let me send, this is the last video. We just were looking at the inverse sign of -7/8. Okay, there's that number. But we wanted a number between 0 and 2 pi. So what do I have to do? Can I split my screen? I'm not very good at that. We have to then, if we want something that's coterminal, if we have this negative value, I can add 2 pi. And now, well, let's see, when I come back, oh, there we go. When I come back here, close out parentheses, I can say plus 2 pi, and now my answer is between 0 and 2 pi, because 2 pi would be about 6.28, and that's smaller than that. Okay, so there's our first one. But now the question becomes, well, one, is that the only way we could write it? And no, it's not. And two, how do I find the one and the angle in quadrant 3? Okay, so let's make this a little smaller. Okay, I don't know, whatever. Looking at this, if we want to then make this for all real, it says find all of them. Okay, so this would become x is equal to inverse sine of negative 7/8. Well, if we're adding plus 2 pi, but I need everything that's coterminal to it, I can just say plus 2 pi k. And so this part's going to give me the very first negative one, and then the 2 pi k lets me then generate all of them. And so that's the most concise way to write that answer. And now let's go think about what else we know. Okay, I'm going to need more space. So pretend that's a nice little unit circle. If this angle right here, I think I called it theta. Well, we would have this angle up here. Let's call that alpha. Let's see, sine of theta was equal to that negative 7/8, then sine of alpha, I'm trying to say it's been reflected up, it's a positive 7/8. Okay, so we can say alpha is equal to inverse sine of this positive 7/8. You see how this y value right here is trying very hard to match this y value right here, except one of them was positive and one of them was negative. Go away. There it goes. So I can either call it, why isn't this letting me there? No, I want this. What is happening? Sorry, you guys. There we go. Okay. I can either call alpha inverse sine of positive 7/8, or I could say that alpha would be equal to the negative theta. Okay, well, what was theta? Theta would be the inverse sine of negative 7/8. And so I could say that alpha is equal to a negative sine to the negative 1 of negative 7/8. So both of those would work for that angle right there. So then the next question becomes, well, how do I then get to this angle that has that same, do you see how they're on the same y value right there? How do I get to this angle in quadrant 3? Well, I can take alpha and add pi, and I have gone, well, that's supposed to be just directly across. And I have gotten to that angle. Well, so what's alpha? Alpha is either sine to the negative 1 of positive 7/8, and then plus pi, or it's a negative sine to the negative 1 of negative 7/8. Woo, it's a lot of negative signs. And so coming back here, actually, let's see. Let's look at sine. Oh, what do we want? We want inverse sine of 7/8 right here. Close our parentheses, and then we're going to add pi. Okay, so there's those two values. Does that look reasonable? Yes, it looks bigger than pi, but not a ton bigger, so quadrant 3 probably. Let's write this down here. So the other one was x is equal to the inverse sine of positive 7/8 plus pi. And so then how do we find all of them? Well, we need to add plus 2 pi k to that. So to find all of them, it would be inverse sine of 7/8 plus pi plus 2 pi k, and for both of these, k is an element of the integers. Okay, let's look now, what was it, 8 sine x plus 7. Okay, let's look at on Desmos. If I do y equals 8 sine x plus 7, okay, here's that graph, and that looks like what we expected. No, it doesn't. Did you see my mistake before I caught it? Close the parentheses. Now let's say plus 7. There we go. I'm like, why is this wrong? So here I see we're at 0, 7, so our midline is there at 7. So what I want to look at, we went as high as 15 and as low as -1, which I knew. We want to see what these zeros are. So I'm going to predict that this first 0 is equal to 4.207, whatever. Let's see. Hallelujah. Okay, sure enough. Now let's look at the other one. It should be that first answer, and it's 5.2177749, whatever. Okay, do we feel good about this? Hopefully we do. And then, so all of this, I wanted answers exact, and it's just kind of annoying. Do you think we need to do the sign diagram? I kind of think we're okay. And then the intervals where it's greater, we would go from 0 to the quadrant 3 answer. Which is the quadrant 3 answer? This one right here is the quadrant 3 answer. You know what? I have this. I think I already worked this. No, I have to come back this way. Okay, here's what we're ultimately going to do. It just didn't seem like you needed to watch me do all this. So it's going from 0 to the quadrant 3 answer for the positive, and then the quadrant 4 answer to pi over 2. I lied, 2 pi. And then it's between those two where it's less than 0. And then, okay, so what did let me see if I wrote this out for my answer key. I said that theta would be equal to the inverse sine of negative 7/8, but theta with the inverse sign has to live between negative pi over 2 and positive pi over 2. But we want our answer on the domain from 0 to 2 pi. So since it was in quadrant 4 and we got to quadrant 4 the negative way, we then have to figure out how to write it as something between 3 pi over 2 and 2 pi, which we did by adding 2 pi. Could we name that angle a different way? So we looked at its reference angles. Okay, I think we talked about this. So we could say that it's 2 pi minus alpha. Oh, you could write it that way. Yeah, or you could, so there's a few different, and I think AP is kind of likely to do that, where they'll write it in some convoluted way and make you figure it out in the multiple choice. So practice. How do we find those solutions in quadrant 3? This is where I said, okay, so it's alpha plus pi, and then pi is either, or the alpha was either negative inverse sine of negative 7/8, or it was inverse sine of positive 7/8. So both of those would work for that solution. All right, like, subscribe, comment, and go practice, because if you don't lock in, you'll make me crash out. Good luck. Go practice.